Hello, welcome to video 34. This video is all about energy, and I'll get into energy efficiency with it as we work towards some of our fuels. So this is kind of where we're at today. We used a lot of wood early in the days of the United States, and that kind of peaked in the 1880s. And then the wood reserves kind of started to dry up. The big forests were cut down where people lived, and so we switched to coal. And coal is kind of peaked in 1920, and it's been on the decline since, and now we're kind of in that oil and gas age, and both of those are reaching their peaks. And so we kind of have these limited supplies, as proven by our past, of energy, and we need to make sure we're conserving them and using them efficiently to prolong their use and kind of delay the inevitable. So first of all, what is energy? Energy is the ability to produce, change, or do work. Remember, work is force times a distance. And so we're going to move something a certain distance with energy. And we can use energy to produce light, heat, motion, sound, growth. There's probably a lot of things that are on that list, but you get the general idea. There's two types of energy. There is the potential energy, which is stored. And so things like fossil fuels are going to be chemical energy stored within the bonds of those atoms. Nuclear energy is stored within the nucleus, and we can release them in nuclear reactors. There's also gravitational potential energy. This would be like dams and things that hold water at a high height and then let it flow back down and spin a turbine. We like to store energy, and then that allows us to convert it into kinetic energy. And so kinetic energy of electricity is the movement of electrons. We might also be spinning a turbine or turning the axle of our vehicle with kinetic energy, or sending electrons through a television so we can watch TV. Energy conservation is really important, and there's actually a law about it. When we use energy, we aren't destroying it. All we're really doing is changing its form, and it's becoming something else. And so here's kind of a little tree. If you eat the ice cream cone, that gives you the energy to move. If you use the chemical energy stored within gasoline, that gives your car the ability to move, and so on and so forth. So it's never destroyed. It's not lost. It's transferred to something else and somewhere else. And so, right, this chemical energy that we put into that's in the ice cream cone that went into the person, that energy from the person is going partially to move the bicycle and get it moving. It's also going to be used to produce body heat and produce sounds as they're banging their pedals around and stuff like that. And so it goes a lot of different places. Energy efficiency is kind of the main topic of this video, and energy efficiency is how much useful energy we can get out of a system. Unfortunately for us, there is a law, the second law of thermodynamics, that works against our wishes. And what the second law of thermodynamics says is that as we convert it every single time, we lose some of that energy to a less useful form. And so if we are going from the chemical energy in the ice cream cone to the person's energy to move the bike forward, some of that energy is lost. That energy lost is typically in the form of heat when we overcome friction. And so this is true in your car, right? Your car, you put chemical energy in the form of gasoline with the goal to move your car and yourself inside the car a distance. The problem is some of that energy gets lost to heat. It also gets lost to sound and light, right? The explosions within your internal combustion engine would produce light. We can't see them because they're within the engine, but it's there. And so this gives us that concept of energy efficiency. And for a human body, it's about 15%. So it's not very efficient in terms of the energy put in, but you're very warm-blooded, and so a lot of that energy, the food and molecules you're eating are breaking down within your body, and when they break down those bonds and those molecules, that energy is becoming heat. So some benefits. Why do we want to become energy efficient? Well, number one, it's going to reduce foreign oil imports, and so this is going to kind of make us more independent of a nation, which is generally a good thing, because if foreign oil were to cut off, we'd be kind of in a lot of trouble. And so if we can use less of it because we're efficient, that's great. It also prolongs it. So like we said earlier, all these fossil fuels are going to run out eventually. Coal, wood, well, we can replant the trees, but oil and gas, all those are going to run out within the human lifespan. And so we can prolong the use of them by improving energy efficiency. We're using up less than we're using them at a slower rate. Other benefits to this is by being more efficient, we don't need to extract quite so much coal or natural gas or oil, and so that would reduce pollution in the burning of it or environmental degradation in the extraction of it. it's cheaper, right? If you are driving a more fuel efficient car, you're paying less because you're using less gas. Same is true for a house, same is true for a city, all of these different things. It also, being energy efficient, allows us to prolong the inevitable, right? Prolong the inevitable and develop new technologies. And so it's given us the chance to create solar panels or wind turbines and kind of alternatives for when we do run out. And then lastly here, right, it creates jobs. This is a good economic thing. There's a lot of great paying jobs out there in the green energy fields, and I would encourage all of you to explore them post-college. The energy efficiency, just kind of another little tidbit fact here, 84% of the energy we generate commercially in the United States, the power plants, the commercial power plants, 84% of that is wasted. 41% is just due to the unavoidable thermodynamics. The other 43% of that would be due to kind of human actions. And so our actions are playing a big role in this. I'll go over a couple different things we can do to help improve our energy efficiency and hopefully give you some good tips for your life and for your house and for your home. So first I want to look at is cars. And so this is our mile per gallon average, and you see some country lines. So here's the good old United States right here. My yellow pen is not the best choice for this slide. Let's change it up and go with red. All right, so here's the United States, pretty low in terms of standards. This is good, right? We got a lot of room to improve. If you look back to 2002, our average was probably about 23 miles per gallon for all domestic vehicles on the road. Compare that to a place like Japan or Europe where there's less space, fuel is a little bit more expensive over there, and you see much more efficient vehicles. So we've got a lot of room to improve this upwards in the future. And so this would save us a lot of money individually and as a country if we could increase our fuel economy. Just some common devices to point out to you, energy efficiencies in percentages. Notice our incandescent light bulb down here, real bad, poor energy inefficient structure here. They produce a lot of heat. If you have incandescent bulbs in your house, you have to be careful not to touch them after they've been on for a while because they do create a ton of extra heat. Here's your typical automobile engine, your internal combustion engine. Probably a lot of you drive around behind one of these every day. A diesel engine is a little bit more efficient, and so switching to diesel fuel would be a good idea in terms of energy efficiency. They typically get higher miles per gallon. And then you see a couple of the other ones here. Notice that nothing is ever going to be 100% energy efficient due to the second law of thermodynamics. All right, so ways we can improve our energy efficiency in our vehicles and how we get around and transport ourselves. And so there's something called CAFE standards. These standards I'm going to get into in a little bit, but let me just kind of cover some of the things we could do. One of them is just shifting to more fuel-efficient models, like the ones they have in Europe and Japan. Typically, they're smaller cars that are more fuel efficient, and they account currently for a small fraction of the car sales. You might see a smart car every now and then, but there's not a lot of options. I know Fiats are becoming more popular. You see Mini Coopers every now and then. So these size of cars are more fuel efficient, but they haven't caught on down here. Part of the reason why we don't see this is the automobile lobby. They like selling the cars that they're selling, and change is always going to cost a little bit more money for them. Hybrid and electric cars, we're seeing a lot of these rising in sales, especially these Teslas are pretty awesome vehicles, and these are true electric vehicles, and so they really are fuel efficient in terms of oil and gasoline. They don't burn any, but depending on how you generate your power, they might be using fossil fuels. And then fuel cell cars are a little further off. You don't hear nearly as much about them currently as you do with the electric cars. The CAFE standard stands for the Corporate Average Fuel Economy. And so what happened in the 1970s is we got into the Gulf oil crisis where the price of oil shot up. Gasoline was very expensive. And so car companies and the United States public in general kind of panicked a little bit. And we set these standards. And what the standard does is it kind of sets for a single company a fuel economy standard they must reach for all the vehicles they produce that year. So say for the year 2017, Ford Motor Company would have to reach an average fuel economy for all their machines of a certain limit, and that's what the CAFE standard. If they don't reach it, then they have to pay fines and fees for going beyond it. And so it's based on the size of the car. So like a big pickup truck would have a more lenient standard and could have less fuel economy. Smaller vehicle would have to be required to be more fuel efficient, but the whole brand of Ford would have to fit into it. And so this graph shows you how productive it's been. This is our pre-CAFE line here for fuel economy, and the pre-price of gasoline for fuel economy. And so you can see after we enact it, they both shoot up for a little bit, and then they kind of level off. And so one of the ways we could really improve our energy efficiency is if we went back to the CAFE standards and increased them further. Home efficiency, right? So in the house, there's a lot of room for improvement in energy efficiency. This picture here is a picture of a house in Boston. And you can see in the infrared camera here where all this heat is leaking out of the house. The brighter the color, like these doors, means the more energy is being leaked out. And the darker the color is, the colder it is. So you can see the roof is pretty well insulated. It's very dark up here on the roof. But look at how bright these windows are. They're losing so much energy through their windows. And so there's a lot of different things we can do to do energy efficiency. One of these things is to add insulation. And so within the walls, this would be drywall or pre-drywall. You can see how insulation's kind of rolled in. We have the walls here. We also have the ceilings here. And that's going to reduce how much heat can transmit through the walls. If you look at the picture, the walls here aren't emitting nearly as much heat as what the windows are due to this kind of insulation. And that's always going to be true. The wall is going to be more energy efficient, more insulated than any window will be, regardless of how fancy and expensive your high efficiency windows are. Plugging leaks is another big one, right? If air can move through the walls through certain features in your home or gaps or holes or stuff like that, you're going to lose a lot of energy efficiency this way. Use a lot of heat to the environment, or you're going to get a lot of heat from the environment in the hot months. And so this is some of the common places of where it leaks out. Energy saving windows. We talked about these in class. Double pane window. The important part is there's a gas fill, and usually it's krypton gas, really big, heavy molecule of gas that doesn't like to move very much. And so when energy strikes this pane of glass, it transmits into these krypton atoms and will speed them up. Because they're so big and slow, it takes a lot of energy to get them moving. And so it's very, very good insulator. Here's a picture of infrared of two different windows, and you can see a insulated window here, how much heat leaks out of it, and then check out the picture right next to it. Look at how cool and blue that is. It's very good at holding in the heat. The next one is wrapped hot water heater. And so this is probably what you see in your garage for a hot water heater. What happens is you've got electric coils in here that get really hot, and they warm the water inside. And then as you turn on your shower, it uses water from this, and then it replaces it with fresh water from your hookup to the city water lines. And so this is your hot water heater. This would be to insulate it. And so by just having a plain metal exterior, you're leaking out heat to the environment, and it might be a little warm to the touch if you were to touch your hot water heater. That's energy and money that you're losing due to inefficiency. Tankless water heater. So even better than an insulated tanked water heater is tankless. This one is going to make hot water as needed, and so it doesn't store any. So because it doesn't store any of that hot water around, it doesn't lose any extra heat to the environment. And so these are much more efficient. You get hot water kind of on tap. It's quick, it's very responsive, and it's extremely efficient. The problem is they cost more than our previous tanked water heaters, and so that's why they're not in a lot of homes. It's relatively new technology. Next big thing is Energy Star appliances, and so this is the logo you would see stuck somewhere to your appliance, usually prominently featured, because it is a good thing to have an Energy Star appliance. These ones are certified by the government to use less energy and electricity than a non-Energy Star appliance. Some other ways you can improve would be super insulation, and it's essentially having thicker walls with more insulation between them. But there's some more really fancy technical features you can get into if you have an interest in architecture and building design. Generally, though speaking, it's more expensive initially for any of these improvements, the ones I previously discussed or any others, but they will pay the savings back in the lifetime of the material or of the appliance. And so it's tough to convince people to spend more initially, because that initial price hit is the biggest and most notable one. But every single month you're saving money on electricity with them. Eventually it will recover the cost. All right, and so the next one here is cogeneration, which the name sounds kind of fancy, but it really explains what this is very well. So we are generating electricity together, right? Cogeneration. And so we're burning fuel. Fuel's being burnt in this engine. And when it burns, we get two sources of useful energy. The first one is the kinetic energy to conduct the electricity, right? And so when we burn the fuel, we are able to spin the turbine and generate electricity over here, which is great. We want to do that. But The cogeneration portion of this, the part that's a little bit different, is the hot water that the engine produces, right? Because the engine's going to make heat as it overcomes friction. That hot water can be sent to a heat exchanger, and we can then use that hot water as hot water for appliances and in bathrooms and showers and washing machines, or we can use it as a hot water heater and actually have these radiators in the building that's using the heat generated from the engine. And so this is very high efficiency because we're using that waste heat productively. And so it's kind of this wonderful technology in that the stuff that previously is thought of a waste and we dump away and we get rid of, now we're reusing it and using it for a useful purpose that we would normally be burning more fossil fuels for. Recycling is also going to be a big conserving big way to conserve energy. And the way to read this graph is that, so we've got our different supplies over here. Textbooks you guys are pretty familiar with. Glass you're probably familiar with. Paper from the office. Steel cans. These ones here, that would be plastic. Copper, carpet, aluminum cans. All of these different things. If we recycle 1 ton of that material, so we recycle a ton of glass, 2,000 pounds of glass, we would save 2.7 million BTUs. And BTU stands for British Thermal Unit. It's one of the measurements for measuring electrical energy. And you can see just how efficient some of these things are. If we save a ton and recycle a ton of aluminum cans, we are saving 206.9 million BTUs. This energy here that we're saving, that's coming from extracting the aluminum from the earth and processing it and putting it into these useful forms, minus out the cost, energy cost of recycling it. And so this is a huge factor. We can save a lot of electricity. Another big way we can do this is by updating the power grid. And so we kind of live in this analog system where our grid is essentially a centralized network where we've got the power plant. And that power plant generates all the electricity, and it's connected to everything else by these really long electrical copper wires. And so it's constantly hot. These wires have electricity running down them all the time, and it goes here, and then it goes to the house, and it goes to the industries, and it goes to the factories. But it all generates from here. It travels many miles, much distance across these lines. And we lose a lot of that due to the second law of thermodynamics. The longer the wire is, the less energy we're going to get out of it at the end. So the kind of the way of tomorrow is this smart, digital, decentralized grid. And if we can decentralize it, where we generate solar power up here, and we've got a CHP plant over here, and we've got wind power over here, and all of these different things then distribute to their local area, and we send the electricity from the solar plant to the grid, and from the wind plant to the grid, and then from there it can move on. You're getting kind of localized power, which is really kind of an exciting idea and technology that this is kind of the future right here, and to me that is really exciting. So the sustainable future, what really do we need to focus on? What can we do ourselves? And the first one is to increase these fuel efficiency for vehicles to reduce our consumption. That could come from CAFE. We could update this and kind of increase those standards, push those mile per gallon averages up. That would be fantastic. But you can also vote with your dollar, right? Purchase vehicles that are more efficient because it will save you money in the long term, and because you're kind of prolonging those fossil fuels till we can find efficient and useful alternatives. We can mandate government purchases of efficient vehicles and appliances. And so the government uses a lot of vehicles, a lot of appliances in government buildings. If we can set the example kind of here and mandate that they must be efficient, and then offer tax credits to the people, the public, the private individuals that do so as well, that would really push towards improving efficiency. We can also encourage independent power producers. And so what this would be I could set solar panels up on my roof and then generate electricity from them. If I generated more electricity than I used, the idea is you could sell it back to the grid. And so I would be selling electricity to the power company. Imagine how fast those solar panels would pay for themselves if I was able to do something like that. And then kind of the last thing here is to cut subsidies from non-renewable energy and provide them to renewable. And it's kind of time that we stop handicapping the field for these non-renewables. Oil and gas has had its day. Let's send these subsidies to the renewable energy field and really drive the research and the improvement there to turn this into a viable alternative and kind of prepare ourselves for when the fossil fuels are going to run out. And so that's kind of where I'm going to stop here. I appreciate you guys watching the 19-minute long video. please bring me some sort of notes and be prepared to discuss tomorrow. I'm really excited to go over this stuff. This energy efficiency is really is the future, and what we can do in a small way to improve a lot of the things we've talked about in this class. So thank you for watching.